Hello again, Algebra 2 class. We've got two more properties of logs to look at in this video set, the first of which is the power property of logarithms. So this deals with what happens when the argument of our log has a power on it. For example, if we have log base b of a to the p. Now, what the power property of log says is that when that happens, when we have that power on our argument, we can actually take that power and bring it way out in front. So log base b of a to the p becomes p times log base b of a. Without doing a full proof, we can just kind of look at an example to make sure this makes sense. So let's say we have log base b of 10 squared. Well, 10 squared is the same thing as 10 times 10. So this is log base b of 10 times 10. And from the last video, we know that when you have two things multiplied inside of a log, it's the same as adding those separate logs. So we can rewrite this as log base b of 10 plus log base b of 10. Well, now we have log base b of 10 here and log base b of 10 here, which means we have two log base b's of 10. So we have 2 times log base b of 10, which is exactly what the power property predicts we would get, right? It predicts that we would bring that 2 out front and we would get 2 log base b of 10. So they seem to agree, which is good. Now, what might this look like in an example? All right, so here we have a couple logarithms that we want to apply the product property to. We want to express them as a product instead of as a power. So in this case, all we have to do is remember when our argument of our log is raised to a power, we can bring that power out front. So it's going to become 5 times log base 3 of x. And that doesn't simplify any further from there, so we're all done. Down here, again, we have a power on our argument, so that power can come right out front. So this is going to be k times log base 5 of 5. Well, log base 5 of 5, remember, is asking 5 raised to what power gives us 5? Well, 5 to the first gives us 5, so this just simplifies to k. There are other applications of where it might be useful to actually apply the power property in the other direction. For example, here, we know we have matching bases here, and we're adding, so we probably want to be able to condense this into a single log. But I'm not really sure yet how to deal with this 5 and this 3 out front. However, the power property lets us not have to worry about that, right? We can move the 5 to be a power of k, and we can move the 3 to be a power of z. So we can rewrite this as log base 6 of k to the 5th plus log base 6 of z to the 3rd. And now I can apply the product property, because we have matching bases and we're adding, and I can rewrite this as log base 6 of k to the 5th times z to the 3rd. And now I don't have to worry about, well, what do I do with that 5 and that 3, because using those two properties together answers that question. Last property I want to look at is the inverse property of logarithms. Now, pretty much what this says, remember from class we had said that logs and exponential equations were inverse functions of each other. Now we know that that means that their inputs and outputs are switched, but it also means, if you think back to our inverse lesson, that they cancel each other out, right? They undo each other. So what that says is that log base b of b to the x, the log and the exponential undo each other, and we're just left with x. The less obvious one, I think, is going the other direction, which says that b raised to the log base b of x is also just x. And this still makes sense because these are inverse functions, So when I apply them one right after the other, they will cancel each other out. Now that's a little simplistic of an explanation, but that's pretty much what's going on here. So what would this look like in an example? Here we're asked to simplify each logarithmic expression. So we know in this first one we have log base 4 of 4 to the k minus 1. Well, we just saw in the last slide that log base 4 of 4 is going to cancel each other out, right? Those are inverse functions of each other, as long as we have log base 4 of 4 to the something. In this case, that something that's going to be left behind is just k minus 1. Now you could also get to that same answer using the power property and then knowing that log base 4 of 4 is just 1, but this way is a little bit faster. Similarly down here, we have 11 raised to the log base 11 of 2x plus 1. Well, 11 and log base 11 are inverse functions of each other, so they also cancel each other out, leaving us with just 2x plus 1.